Okay, so let's take a look at another electromagnetics question. Here we are told two current-carrying wires are observed to repel each other. If the current in one wire goes up, what is the direction of the current in the second wire? All right, so let's draw a little diagram. Let's draw two current-carrying wires. We have one here, we have one here. Now we are going to assume that they are parallel. This is an assumption we're allowed to make in this type of question. We're told the current in one of them goes up. So the current here, I1, goes up. Now these wires are repelling one another. So this means that the force on this first wire due to this current in the second wire goes away from the second wire, and the force on the second wire due to the first also goes away. This is what it means for them to repel. Now we need to work out what direction of current would produce a force away in the second wire. Well, there's a few different ways to do this. You can think about how forces are produced and then use your right hand rule, or you can have memorized the two different orientations. So if you're doing this from memory, you'll say if the currents are in the same direction, they attract; if they're in opposite directions, they repel, and immediately you can calculate that it has to be the opposite direction. However, if you don't have that piece of information memorized and you only have access to your right hand rule, you can calculate the magnetic field for the first wire, use that to work out what the magnetic field vector will be on the second wire, use that combined with the force to work out the current vector. So we're going to do this because it's good strategy to be able to do these in this way. So we have a current going up, we have a force going to the left. So our thumb has to point in the direction of the force, our index finger has to point in the direction of the current, and our middle finger is going to point in the direction of the field. So in this case, the field is going to go into the page. The field is going to go into the page. So if we look at this from above, the magnetic field vector from the other wire goes this way. This means that the orientation of the magnetic field on the second wire is, when viewed from above, clockwise. Now, using your right hand rule, if you wrap your fingers around clockwise, your thumb points down. This means that the current in the second wire must be going down. So I2 must be going down. And this was the answer to this question. You could do it shorthand by having memorized the orientations. For this, it's pretty easy to memorize them. If they're the same, they attract. If they're opposite, they repel. But you can also think about it using right hand rules.